Hello, NoNameCon. My name is Alex Jay Balan. I work for a cybersecurity company called Bitdefender. And today I'm going to talk to you about exploiting bad cloud implementations in IoT. Essentially, this is the third presentation in a series. This is why it's called Next Gen IoT Botnets 3, More Ownage. And we've been doing this for the past maybe 5, 6, 7 years. And I'm happy to say that we've got a lot of good feedback and positive feedback on our research so far. We've managed to kind of break down and get vulnerabilities in more than, I guess now it's about 35 devices, IoT devices, amongst which some of the very popular ones. So again, today, this session is going to be about bad cloud implementations. And also, I think it's worth saying that this is a recorded session. It's so the guys from NoNameCon, NoNameCon, sorry, asked me whether or not I wanted to do a live session, a recorded session, or some other variant. And just out of curiosity, I wanted to do a recorded session, a pre-recorded session, simply because I've never done that before, and I wanted to see how this is going to go. So. About me, I work as Chief Security Researcher for Bitdefender. I have a lot to do with IoT research. I work with several teams that do IoT research. And I also manage the bug bounty program at Bitdefender and a lot of the vulnerability research part. And for this particular presentation, we had 3 main contributors, and that would be my colleagues, Radu, Alex Pasaraba, Alex Lazar, and a number of other people from the Bitdefender labs. So moving on, this is a small clip from a movie with Cameron Diaz, in which this is kind of what we feel some companies understand about how to do cloud implementations in IoT.
You know the cloud? Nobody understands the cloud.
Yeah, well, because pretty much most of the time, as we've seen, they kind of do the implementation out of the box, and then don't necessarily look for whether or not they've done a good job about it, as we're going to see further on. So let's start with defining IoT. And while this may sound a little bit boring for some of you guys, you're going to see that it may not be exactly how you see it. So IoT is a stack. So let's start let's start with a few stacks, right? So you have hardware, an operating system, and an application layer. So in this case, you have hardware, Red Hat 6.2, and for those of you who are older, or at least as old as I am, VuFTPD, which was a renowned vulnerable application back in 1999. Then let's say you have like hardware, an operating system, and the IIS web server 5.0, which again was an extremely hacked service back in 1991, 1999, 2000, 2001. So you have another stack like hardware, Windows operating system, and RDP. And another stack called, hardware, whatever operating system, and Joomla web application. And you're going to notice that at the application layer, I've added stuff that was known to be hacked at some point in time, right? So VuFTPD, IIS 5.0, RDP, Joomla, all of them had some serious vulnerabilities that enabled hackers to kind of compromise them at some point. Now, bringing this within the IoT space, in the vast majority of cases, you have hardware, an operating system, which is like BusyBox in the most common scenarios, and the hardware is very often either MIPS or ARM, and then you have an application layer built on top of that BusyBox. And that BusyBox, for those of you who don't know, though I guess most of you do, is a stripped-down version of Linux that's designed to work on very small / embedded hardware. And besides that, in IoT, we have 2 additional components. You have a mobile app and you have cloud. Because today in 2020, 99% of all IoTs are cloud connected, and managed by a mobile app. And that mobile app usually talks to the cloud, and then the cloud relays those commands to the IoT itself. And then, of course, this kind of extends the attack surface, right? So in the old days, you had like only the application layer or maybe the operating system as an attack surface. Well, right now, you also have the mobile app as an attack surface and the cloud as an attack surface, as we're going to see further down the road of this presentation. So essentially, IoT is just a small website, because in 99% of the cases, that application that stays on top of the operating system is a web application running on Linux, but with a significantly bigger attack surface due to mobile apps and cloud. And the reason I'm saying they're just websites is because, again, in most cases, that application is a web app. And that means it's subject to all the most common exploits running in web apps, except for the fact that it's very often outdated. They run some CGIs, which talk to system commands. In some cases, they run PHP. In many cases, they have command injection. And very often, you can even find buffer overflows, because that app is designed to not be interacted with directly. It's designed to only talk to the cloud. And that's kind of security by obscurity, as we're going to see further on, because they believe that since a user doesn't have direct access to that mobile app, there's no open ports on the device or whatever, then there's nobody to actually try to, you know, brute force it or find a buffer overflow or interact with it in any way. And that's wrong. So just as a quick prologue, for those of you who want to get into IoT hacking now, and just want to get started and have some easy, quick and easy wins, here's what to look for. First of all, you have the software part, and sadly, Telnet is still a thing. And I'm sorry if this says 2019. I've stolen this slide from a presentation that I was doing last year, but it's still a thing in 2020 as well. Then you can look at the mobile app / device communication. So essentially, you're going to want to set up a small man-in-the-middle device that analyzes the way the mobile app talks to the device and the way the mobile app talks to the cloud. And then you're going to want to try to impersonate the commands initiated by the mobile app. You're going to see HTTP requests, HTTP post requests, HTTP GET requests, and you're going to see APIs with which the mobile app interacts. And you're going to want to fuzz those commands. You're going to want to try to alter those commands and try different commands to see, whether or not you can trigger different types of unexpected behavior in either the device or the cloud API. And with this, you're going to be able to probably reach command injection. There's a lot of directory traversal, especially in the IoT itself, if there's any open interfaces on that, local file inclusion exploits, and buffer overflows. And this is the part where it's worth mentioning that, and this is very important, in the vast majority, if not all IoT devices, the binaries are compiled without the position independent executable flag. So I'm sure that most of you are familiar with ASLR, right? And essentially, in an operating system, ASLR enables for a binary to be moved at random memory locations when it's executed, in order to prevent command execution when somebody manages to get a buffer overflow, to find a buffer overflow. And well, yeah, ASLR does that. But in order for ASLR to work, the binaries themselves have to be compiled with a flag that allows ASLR to move it at different memory addresses. And that flag is called PI, position independent executable. And that kind of uses a few additional CPU cycles. And this is why on most IoTs, there is no PI, right? Because there is no PI, if you find the buffer overflow, not only can you crash that executable, but you can also very predictably achieve a command execution on that device. Also worth mentioning that if you find a vulnerability in one device, there's a very good chance that that vulnerability is going to be found in other devices as well. We've seen this a lot. and we've seen vendors that share the same code. We've seen vendors that use OEM code, and in one case, for example, we found a number of buffer overflows and remote command execution vulnerabilities in a security camera. And then when we looked under the hood, we found a firmware that was present in about 20 other different types of cameras with different UIs, different buttons, texts, and so on and so forth. But these vulnerabilities were common to all of them. And that kind of brought up the number from what we initially evaluated at a few 100,000 devices to a few million, all of them sharing the same vulnerability. And as you can imagine, it was a nightmare for us to reach out to all the vendors and get them to patch them. This is why right now, a few years later, there's still roughly, well, I guess at least 500,000, 600,000 devices still vulnerable to these exploits because they didn't reply to our emails, or we couldn't find a contact address to reach them or to reach out to them or something like that. Okay. Another common vulnerability is backdoors and credential reuse, private key reuse. This is common. You're going to see this in any IoT-related talk. Essentially, backdoors would be either service accounts implemented by the vendors or actual backdoors. We've seen a device that if you send a certain string on a certain port, then after that string, you can enter any command. So it wasn't a common protocol like HTTP. It was simply a service port open on, if I remember correctly, 9,000 something, and you had to send a 6-character string, and after that 6-character string, your command, and it would be system executed on the device. Obviously, it wasn't documented; it was hidden, and so on and so forth. But we found it. Credential reuse, obviously, it means that some service accounts, which may be documented, have the same credentials across all devices. This was the main cause of the Mirai botnet. If you remember, in 2016, we had, for example, a password which, let's say, is safe, like XCV-GORI 2941, and this was the password. You wouldn't guess it. However, if you extracted it from the firmware once, because you could find it there, then you could use that password to compromise hundreds of thousands of devices, because they would use the same credentials. And obviously, the users didn't know about that in order to change it. And last but by no means least, private key reuse. In many cases, we've seen manufacturers embedding encryption keys that can be used to communicate with the device in the firmware, and then the same key would be used across all devices. So if you manage to compromise the key in one device, then you're going to be able to reuse that key to compromise all the devices from that vendor. So Cloud Chatter is, again, thing to look out for. Just look at the way the mobile app talks to the cloud, and you're going to see some APIs, and then you're going to find interesting things in those APIs. We're going to talk about that actually later on. So moving on. Other tools to use are, obviously, you can look in the hardware, just open it up, and then find a JTAG interface, or much easier way, find a serial interface. Just again, the vast majority of devices have serial ports, and hooking up to that serial port with either a screen/minicom in Linux or hyperterminal in Windows, I guess, enables you to interact with the device on the serial interface, and you can do boot hijack much like you would do on a Linux machine that you want to change your root password, right? So you just pause the bootloader and then pass parameters to the bootloader to start it up in single user mode, for example, or init equals binsh in this case. And much like a Linux, this is going to drop you into a dumb shell. Then you just remount the file systems, and you can interact with them, add your own users, so you can just log in properly after the next reboot. So we get to today's presentation. So this is the start of it. Traditionally, compromising IoTs, especially from the perspective of IoT botnets, was done like this. You would iterate each IP address in the IPv4 space, and then find maybe an open telnet port or maybe an open SSH port, and then you would brute force that with the most common credentials that you know, and then you get in, you drop a payload, and then you enroll that device into a botnet. Or you find an open web service port, and you try the most common IoT specific exploits, web exploits, usually command injection ones, some CGIs that are getting exploited, some debugging interfaces that are getting exploited. It's not that difficult. But the bottom line here that has to be understood is this was done by iterating IP addresses in the IPv4 space with exposed ports / applications, right? So exposing the internet. Now this window for hackers is going to close, right? Because a lot of devices are not going to be directly exposed on the internet. Port forwarding is, thank God, is dying. UPnP is probably going to die soon as well. So the whole concept of finding open interfaces directly exposing the internet in the IoT space is going to gradually die. So what's a hacker to do? Especially an IoT hacker. So what are we to do if we want to keep compromising devices? I'm not saying we should, but I'm saying, if I put myself in the shoes of a cyber criminal, what would be my next step? So we started researching cloud implementations. So this is how IoTs look right now. You have the IoT, the cloud, and the mobile app. So the IoT in this scenario, again, 2020, is not directly accessible from the internet. There's no open ports. There's no port forwarding. Everything is done relayed by the cloud. Obviously, it allows for more efficient management because you don't need to have technical skills to do port forwarding and have access to it, right? It has a modular architecture, and this is an important thing to mention. And very often, some of the components, like the cloud component, is provided by a third party. The mobile app is provided by a third party. And that's not necessarily a bad thing, because usually you're supposed to build the things that you're good at building. And if you don't know that much about cloud, maybe it's a good idea to kind of call upon a third party to provide a cloud service for you. But as we're going to see further down the road, it's also very important to pick a proper third party to provide that cloud platform for you. And if they tell you this is how you're supposed to implement it, it's ideal if you follow that documentation. Usually, and again, we've seen this across most IoT devices, the IoT registers to the cloud with a unique identifier. Usually it's a 32-bit string, much like the one that you see in the image over there. And this is the thing that identifies that device to the cloud. And this is the thing that is used across the entire communication as an identifier for that unique device. And usually the way this is going to work further on is the mobile app tells the cloud, please send this command to that device using that unique ID as the identifier. And they use encryption. The entire communication between the mobile app and the cloud is encrypted very often. Well, not always, but very often, so that's good. And this is a very generic description of how IoTs are implemented today. It applies to literally 90% of all the devices that we've analyzed. So again, the device registers into the cloud, says, I'm device with this unique device ID. And then the mobile app says, okay, shoot this command towards that unique device ID, or give me the status of this unique device ID, or interact with that unique device ID in this way. So this was great. It's awesome. It's definitely much better than exposing it directly into the internet, and it looks pretty secure. But, well, not all cloud implementations turn out to be that great. So this looks okay the first time you look at it, but it may not necessarily be that great. So, in the vast majority of the cases, there's no additional authentication implemented. This means that there's no, the mobile app doesn't need to authenticate to the cloud, and the device just doesn't need to use anything other than that unique device ID. Essentially, that device ID is considered unpredictable, and that serves as authentication. if somebody knows the device ID, then they will be able to talk to the cloud and send commands to that device ID without any other form of additional authentication required. Arguably, the device ID in most cases is unpredictable. So you can brute force it, you cannot brute force it because it's rather large, it's 32-bit, and it's going to be different for each type of cloud implementation. So there's a very good chance that you're not going to be able to find out which is the device ID that you want to have. But again, worth mentioning that if you do know a device ID, then in the vast majority of cases, there's no additional authentication required to send commands to it through the cloud. Another good thing is some vendors do implement additional symmetric keys unique per device, but that's very rare. So we've only seen that once or twice. And some vendors, and this is going to be fun, and we're going to see it later on, some vendors implement additional functionality in that cloud implementation, quite often breaking what should be decent security. And you know, Amazon S3, MQTT, these are a few common examples. I'm going to detail them in the next slides. Client ID is going to be something specific to a vendor that I'm going to talk about a lot later on. So a few words on Amazon S3 buckets. In many cases, the security of S3 relies in the obscurity of the path where a file is stored. So you have a path, which is like this is the path to the file you want /mp4. And the path is generated by whichever device generates that file, right? So I have a security camera, I generate the recording, I upload it to the S3 bucket, and then I relay the information, the file is in this path, to the mobile app saying you can access it at this path. What you should be able to do is access the file at that path from anywhere, even from any other device, even without authentication. It may not sound ideal, but that path is usually not predictable. What you shouldn't in any situation be able to do is list the files or go up one level in that file path. So if you're going to be able to see the path in the mobile app, right? So when you're relayed the path to a recording, you're going to be able to see the path to that recording in the mobile app. But you should only be able to see that recording. You shouldn't be able to list all the other files in that folder. And definitely you should not be able to go up one level, up one level, up one level to see all the files in that folder. It's much like a web server that has directory index enabled and it shouldn't, right? Usually you should only be able to see the files available from that web service, from that website, which are exposed by the website itself, by the website application. You should not see the directory index of that website. So we've seen an alarming number of vendors that allow the equivalent of a recursive list of the root folder of their S3 bucket. So if you implement S3 it doesn't have to be IoT. If you implement S3 in any way, make sure that you check out for this. Make sure that nobody can recursively list the contents of your bucket. MQTT. MQTT is a new protocol which enables monitoring, alerts, and in some cases commands between mobile app and the device. And the way it works is that the device registers in the MQTT servers to something like a /vendor/device ID/topic, where topic is like the different types of events. So I register to /vendor/device ID, which would be a unique string specific to my device ID. And then I would say, I'm online, and then, or topic online, topic offline, topic event happened, topic something, something, something. And then I would relay all these, let's call them paths, to the mobile app and say, you can register to those topics and see whenever something changes in them. So you should only be able to see the topics that the device tells you can see from the mobile app. Now, what we've been able to see in some cases is that while normally as the user, I should only be able to see the topics relevant to my device and register only to the topics that were exposed by my device. We've seen implementations in which you can just register to /vendor and then see all the topics from all the devices used by that vendor. And we've seen this actually live in some cases. And the statuses are, first of all, you can see all the device IDs, which is a great deal because, again, those are the device IDs which shouldn't be accessible. And you shouldn't know them except for your own device ID. And in some cases, the status is I'm being configured and this is my password. So if you manage to see a device to monitor the MQTT stream, and at that point somebody configures the device, you're going to see that person's passwords, configuration, everything that's being sent and updated on the device in the MQTT stream. So here's an example targeted attack in which, let's say you want to hack, you want to get access to somebody's baby monitor, a specific person's baby monitor, Irene's baby monitor. So you register to /vendor on MQTT and have a script just parse all the output of that. It's going to be a lot. You're going to have millions of devices sending you status updates. And you have a script that parses that and then harvests all the registered device IDs. And then with those device IDs, you query the cloud of that baby monitor and get the information of the owner. Because again, as I was saying earlier, very often the device ID is the only thing you need to authenticate with. So you're going to be able to just say, hello, give me the information about this device ID. And then you're going to get the information like, email address, owner, name, phone number, location, all the stuff associated with that. Why? Well, because you're supposed to know your own device ID and you're supposed to be able to pull your own information. But since we're pulling all the device IDs from the MQTT stream, unfortunately, you're going to be able to kind of pull this information about all the users. So when you see Irene's email popping up, you have her device ID and email, and then you go to S3, as I was saying in the S3 bucket slide. In this case, you have /vendor, /device ID, /recordings. And if listing is enabled, you're going to see all the recordings from Irene's baby monitor, which this is a purely hypothetical scenario that we have not done except for our own device, of course. So yeah, this is how you could leverage bad MQTT/S3 implementations. Now, another bad cloud implementation that we've seen was from Edimax. You can find this paper on our website, labs.bdefender.com. Essentially, they had a number of vulnerabilities, but the one that had to do with cloud was an unauthenticated remote command execution because of the way they would change the password on the device. So when the power outlet would talk to the cloud, and then with the mobile app, they would need a form of authentication between the power outlet and the mobile app. And the way they would check that authentication is that they would MD5 their password, both the mobile app and the device, and then check if the hash sent by the phone is the same with the hash resulted from MD5ing your locally stored password. If the hashes match, then the communication is established. Now the problem was that the power outlet was using the system MD5 command for checking that hash. So if you told the cloud to change the password to semicolon whatever, then you would get command execution. So as a proof of concept, what we've done was we changed the password to semicolon, FTP get, meterpreter payload, connect back meterpreter payload, and execute it. And then we send the command to the cloud, and then we got a connect back shell from the power outlet from across the world. We did this demo at the security conference in China a few years ago. And unfortunately, that password function is hidden. No user changed it to the best of our knowledge. And the only identifier that you need to talk to the cloud is the device ID, which in this case was the MAC address of the device. So definitely, but this was also predictable, brute forceable, and they have 2/16, well, two 16-bit ranges of MAC addresses, which essentially enables you to kind of get the root access on literally all of their devices. And I think that this exploit works to this day, because even though they issued an update, the update, we were not able to apply it. So apparently nobody applied that update. So moving onwards to Guardzilla, the smart security camera. Now, spoiler alert, they just closed shop a few weeks ago as I was preparing the presentation for this conference. So we're probably not going to be able to see live demos on how to hack these, but I'm going to be able to tell you at least how we did hack it, the process that we went through, what happened, and well, a few details about the vulnerabilities that we found and how to exploit them. And this is reusable information. So this is the kind of stuff that you can actually, learn from and then reuse for other research that you're doing. So we started with analyzing the mobile app. And we saw that the mobile app talks to an API endpoint, HTTPS apps.guardzilla.com. And after we registered our initial account, because they required you to register an account, the app receives a 6-digit long UID, which would be something called a client ID. And that 6-digit in our cases was 408311. So 408311 was our client ID. Do you see anything wrong with this? Well, yes. It's a 6-digit number, fully predictable. This means that the next customer's ID is going to be 408312, and the one after that 408313. So essentially, you have a fully predictable range of client IDs that you can interact with. And it cannot be changed, and it's incremented by 1 for each account. So what can you do with this client ID? Well, they have a hard-coded password, again, the same for all their customers. You query the cloud with the client ID and with these parameters. And then, yeah, sorry, I forgot to mention that the post requests are encrypted with AES-256. However, the encryption key and the initialization vector were hard-coded in the app. So you can essentially replicate the entire mobile app behavior. However, you can also script it into your favorite Python, Bash, whatever, to interact with any of the client IDs that you want. So this is what we did. We replicated the entire mobile app interaction with the API. We used the encryption key, and we started posting queries to the cloud. And this is the reply that we got back. And this is the reply in a more beautiful format. So you post the request to the Guardzilla cloud, and you say, tell me all the information that you have about 408311. And this is the kind of stuff that you get back. So this device has 2 cameras associated with it, in this case 3 cameras associated with it. This is the password for each camera, and this is the device ID, that long, non-predictable identifier that I was mentioning earlier for each one of those cameras. Now, what happened here was that they used a cloud platform that says, we're going to use the device ID and the password to manage the cameras, manage the devices. And then Guardzilla said, okay, and on top of that, we're going to add something called a client ID. In this case, is the UID, the 408311. And so we can manage multiple cameras for one customer. So this was one of their biggest mistakes, because obviously this is predictable. So you see the device IDs, you see their passwords. So from this point onwards, you can, do anything you want with these cameras. Oh yeah. So worth mentioning that you can change the password, and some users do change the password of the camera. But unfortunately, it's useless, because Guardzilla is just going to keep telling the attacker, this is the password, this is the password, this is the password. So no matter what password you set on it, all you have to do is just query the Godzilla cloud, and then it's going to tell you this is the password that's being set for this device. So the first thing that we did was, okay, how can we do account takeover? There's APIs, not documented, but we found them anyway. You can change the email, and all you have to do is just send the client ID and the new email that you want to set. And this is going to change the email of the owner of the account, and then just take over the account of a customer. So there's no confirmation email sent, and the old credentials are invalidated. Again, the only thing that you need for this is the UID. That's all, the client ID. We wanted to get access to the video feeds, so initially we did it the hard way. We wrote a client that pipes the video feed of a camera to a local pipe, and then you just read it with VLC. It wasn't beautiful, it kind of crashed, but it worked. And again, what you needed as parameters is the device ID and password, which you got from querying the cloud. And then we found an easier way, which is invite somebody to view my camera. So there's this option in which you can invite somebody to have access to your security camera. And this is also callable in the API. And the cool thing about it is that there is no notification to the owner that somebody has access to the camera. There's no notification to the owner that somebody was invited to view the camera or is invited or has access. So all you have to do is just call upon this API, invite yourself, and watch the camera, and the owner will have no idea that this is happening. So I know that the talk was called Next Gen IoT Botnets. So let's talk about how to get a root shell on these devices. So first of all, we found a buffer overflow in the Cloud Agent. Essentially, the Cloud Agent is provided by a platform called Kale, and there's a combination of peer-to-peer relay servers that are used to bypass NAT. And there's the binary called main v5.14.exe on a Linux machine that handles a number of services, including cloud communication. So in that exe, so when we put it into the disassembler, we saw a function called TKset device model request handle. And this was found to be vulnerable to an out-of-band writes. So a specially crafted buffer sent to the cloud will get at RC, because again, buffer overflows do not, I mean, you can get RC from buffer overflows because ASLR does not work. So what we're doing is that you can see here in the TKset device model request handle, you can see that there's a V28 and V29. So these are the names that our disassembler gave to the functions. And as a funny story, we also found the source code on GitHub later on with proper names for these. But for the sake of this presentation, we're going to use V28 and V29. So we overflow V28, then V29, and reach the return address here. And as you can see, we have system. So we can just call system from there. And then this is the entire exploit. So all we gotta do is just send this buffer, and that's it. And the main binary is gonna crash, and then, well, it depends. Each person can do whatever they want. In this case, we wanted to add something to the startup, or you can get a connect back shell, different things. So we do have a movie, because unfortunately, right now, the API is dead. It's so dead that if you profiles, presentations, so it's so dead that if you try this, yeah. So we're gonna fall back to movies. So this is buffer overflow. Essentially, we're setting up a listener. We're using our own script that emulates the app to get the details of the device that we want to hack. So essentially, we're asking, tell me all the information about 408.311, and then we're getting back, okay, this is the device ID, 5PK, MK, and so on and so forth, and this is the password admin. And with this information, we can just tell it, okay. Then we have this app API client, which would be our exploit that says the buffer overflow. And this is the command that we want executed, create a netcat connect back shell, similar to netcat with mknode because they don't have netcat. And this is the shell that we got. Another RC is a command injection that we found in another version of the firmware, so another one of their cameras. Essentially, in the update process, they use a system command to unpack the firmware. So all we got to do is trick it to unpack something that has a semicolon in it. Yeah. Unfortunately, again, we're going to use movies for this. Again, the demos are simulated to be fully remote, right? So all of them are designed to pop up connect back shells. So once more, we try to get the device ID by using the get UID script. We got it. It's BLEMNC, admin is the password. And this is the command that we're injecting. Pop, send a connect back shell with netcat. And this is the connect back shell. So this works fully remote, completely behind maybe 3-4 NATs. It doesn't matter. Again, fully remote from any server. When I did this at a previous conference, I used a server in Canada and compromised the camera in my hotel room. And the camera in my hotel room was behind 3 routers, my own router that I use in my hotel room for my own private networking there, and then the hotel's router and whatever other firewall that they had over there. So no direct connection, everything relayed by the cloud, and then a connect back shell from the device to my server in Canada. So unfortunately, you're not going to be able to try this at home because they closed shop. And not only did they close shop, the cameras no longer work. So right now, to the best of my knowledge, there's millions of devices which are literally bricked. And there was no notice. I looked at my customer account with them. There was no notice, nothing whatsoever. And yeah, not a good thing. Okay, as a bonus, as I was saying earlier, S3 is not necessarily the best implementation if you don't do it properly. So there was an open S3 bucket in which you could see all the recordings of all of their customers. We were told by them that they closed that. And then while I was doing this presentation at DerbyCon, somebody in the audience told me that they were looking at the same thing and it's not closed. So to sum up, if we have that initial, in the Godzilla case, obviously, if we have that initial client ID, the client can get all the information about all the devices associated with that client ID. And that client ID is a 6-digit number incremented by 1. And from that point onwards, it leads to a full account takeover, getting access to view the video feed of the device without the owner's knowledge, and multiple remote command executions that you can just get connect back shells from, and literally can hack them from anywhere in the world. Again, without them being directly connected or exposed in the internet. So as takeaways, I think it's worth mentioning that the IoT is a huge attack surface, and not only that, well, many people have no idea about the problems that lie with IoT. It's a nice commodity, obviously, but nobody takes the time to kind of do a very thorough investigation when they get their next, light bulb, power outlet, vacuum cleaner, and so on and so forth. And because of cloud, you can bypass that and you can get root shells in people's houses, right? And it's really scary because it can lead to APT. You can have a root shell in somebody's house for months, simply because they wouldn't know that you're present in that small power outlet that they have, with whatever the air conditioning connected to, right? There's no indication that you're present into their network. And if you cover your connection pretty well, if you use, let's say, an Amazon VPS, then that connect back shell is going to look like a legitimate connection to Amazon. So there's ways and ways and ways in which you can cover your presence into somebody's house. That's a little bit scary, right? So vendors would definitely need to pen test their product periodically. When we published our initial research on Godzilla, after trying to reach out to them for about a year without success, they called me. So they literally linked up with one of our OEM people on LinkedIn, asked him for my phone number, and they called me. Their product management director called me personally, asking why we published. And we said, well, we couldn't reach you. Here are the emails that we sent. And then they said, okay, we're going to do a better job at listening to the community. And I said, great, that's really, really great. But have you done any kind of security evaluation before you put the product into the market? Because having a predictable client ID and so many things depending on it, it's a pretty obvious thing. It took us 5 minutes to find that out. And he said that they did, and they paid a lot of money for that pen test. So I don't know if he was lying or not, or the company that they got was just ticking some boxes in some Excel sheets, doing some automated scans. But IoT security is really not that difficult. So it's not going to work with just running Nessus or running, Nextpose or Acronetics or whatever. It's not going to work with that. But all you have to do is just do some very simple steps, like the ones I've outlined in the first part of the presentation, and that's it. You're going to find a lot of things. So vendors do need to pen test their products properly, run bug bounty programs. There's no better way to do security for your company than bug bounty programs. I'm telling you this from first-hand experience. I managed the one here at Bitdefender. No pen test whatsoever, and no pen testing company whatsoever could find as much as we get from the bug bounty program. So as I was saying, it's still trivial to find RCs in IoT, but one thing that's really, really important is listen to the community, have a channel through which the community can reach out to you. Our biggest issue by far was getting a hold of somebody that says, oh, thank you for telling us this. We try to write at security at company, support at company, office at company, all the spammy emails. We try to look for contacts about them. We try to reach out to them on Twitter. We try to reach out to them on LinkedIn. In one case, there was a really, really serious situation, like a really big vulnerability, and we couldn't disclose it. It was that bad. And we even tried to reach out to the shops that were pushing their products, right? So maybe there was a chance to reach out to them like that. So we went that extra mile in trying to get in touch with the company, and it doesn't really work that well. So definitely as a company, you would need to have a security contact. If it was up to me, I would talk to lawmakers to make sure that no company is allowed to operate without a clear security contact on their website. And that's one thing. And the second is obviously have a proper update, unattended update mechanism. We've seen cases in which the company responded, pushed the update, but less than 1% of the users applied that update. So this is very important as well. Everybody has vulnerabilities. It's a matter of how you find out about them and how you can fix them across your entire user base. So this is a slightly dishonorable mention, the one that I was telling you about earlier, when we tried to reach out to the company on all the channels possible, and we couldn't get to them, and we also weren't able to talk about it because of legal issues. And the really sad part is that the vulnerability is rather trivial. It can be exploited, and it's, well, thankfully we did get a chance. We did get in touch with them eventually a few days ago. So yeah, it is closed now, but it was, at least from the moment we found out about it, a year and a half later, it was still open. So this was my presentation. This was all done in one take. So I hope that it went okay. I know I kind of stuttered every now and then. I had no idea how this is going to work. Obviously, I'm used to having an audience and kind of interacting with them every now and then, so it's kind of weird for me as well. This is my first pre-recording talk ever, so I thank you all if you watched this, and if you didn't, well, I thank you because that you tried. You know, thanks for that. So you can reach out to me. This is my email address. This is my Twitter handle. My DMs are open on Twitter, so don't hesitate if you have any questions. Kind of shoot any questions my way. I will be more than happy to answer. So thank you for your patience and have a great NoNameCon.
So that was a great talk, Alex. And you see, I'm reading comments on YouTube, and people are like so excited about how many scripts and how many different ways you've shown during your talk. So they like, we need slides, we need to see it and read it again. Like, yay! I hope you'll share slides with us, because really there's a lot of details to follow. I have a question for you from our audience. That some vendors think that they can increase security of their software by hiding algorithms and protocols, even if those algorithms are well known. How do you think, does it really increases the security level?
Absolutely not. I mean, we've had a case just recently where a vendor had an encryption key hard-coded, and it was the same encryption key across all of their devices, many millions of them. And their security mechanism was they used ROT 13 to hide the encryption key. So obviously it was easy to reverse and extract it. So no, definitely obfuscation or just hiding the encryption keys or the sensitive data is not a protection measure.
I really enjoyed that the slide that when you explained that software uses IRCBC like encryption, right? But the key and init vector were hard coded in there.
Yeah.
That's our reality, right? Like every day, like most applications are like that. Awesome. One personal question for you. As someone who knows so much about security in IoT, do you on your own, do you use IoT devices like smart bulbs or like security cameras at your home?
I use a Google Home. And I think that's it. I used to have a smart egg carton, but I decommissioned it a long time ago. Essentially, and again, that's just me. I only use devices from vendors that I trust. It's mostly about the vendor and how I see the vendor handling security, right?
So right now you trust on the Google.
Well, I trust Google more than I trust some no-name company that that's obviously not treating security properly. Google has privacy issues. There's no question about that. But on the security side, I mean, they're okay.
Okay. Okay. And you showed this example with those cameras, and you mentioned that the store is closed. Do you think like you are the reason of that?
Well, obviously, at some points in their life cycle, they didn't make the best decisions, and that means that the people making those decisions may not necessarily have been the best people. I don't want to comment any more than that. It's
okay. Okay, no pressure, no pressure. But talking about like smart cameras, for example, there are many companies that make smart cameras, and we know that they may be vulnerable. Like there is a history within different companies with pretty much the same vulnerabilities, right? Who do you think is responsible for that? End users that use this kind of devices, or companies that produce this kind of like weak security devices?
Well, as much as I would be tempted to say that it's only the vendor's fault, I do have. I mean, obviously, you're going to say, well, it's the vendor's responsibility to make secure devices, but we as businesses encourage them to continue having bad practices by not challenging those bad practices. We continue to buy cheap and bad stuff. We continue to accept cheap and bad security practices. And that's on us as well. We shouldn't allow this kind of behavior. We shouldn't allow this kind of practice. We shouldn't allow companies to operate with such negligence about how they treat security of their devices.
Yeah, I agree. And even after incidents, like people just continue buying these things because, I agree totally. On this topic, another question. Do you think if obligatory security certification for IoT devices will be useful and will like make things better?
In short, no. What I would want to see is an obligation for companies to have a security contact and something like an SLA to answer, and transparency in vulnerability management. That's the solution to the problem. The certifications, much like most other certifications on this planet, are subjective. They can be corrupted. Some certification institution may be more easygoing than others. That might not be as rigorous. I mean, let's face it, our secretary from our Spanish office passed the CEH exam, right? And she wasn't necessarily the most skilled of hackers. So certification can be subject to sort of corruption, too much, lenience and stuff like that. But definitely companies, if they have a security contact, and if they transparently manage their vulnerabilities, then that is going to literally make the world a better place worldwide and enhance the security worldwide. But so few companies do this.
Make the world a better place, yeah.
I stole that from Silicon Valley.
Yeah, indeed, like wipes. Okay, thank you. We have like a technical question regarding your slides. People notice that many devices, like or many applications, mobile applications, use post request. From your experience, is it like the most popular type of requests, if I understood the question correctly, or maybe like get in options are like are mostly used or something?
Well, the reason for that is that most mobile apps tap into APIs, and it's usually JSON posts, right? So you usually just call upon the API, and then within a JSON, you just send the JSON, and that's done with a post method. But we've seen gets and posts, maybe not equally, maybe mostly posts, but because of this API thing, because it's calling upon an API, where that's the method used by the API.
Okay, well, from my personal experience, I see that post request is used a lot indeed, just because it's like, Oh, sometimes I really like when email and password are sent as URL parameters in GET requests, just because. Yeah, life happens. Do you remember a story about rental car in California mountains? So there was a story about people who rented a car and they went to the mountains, and then in mountains the internet connection is not the best, and they needed to have this mobile application to enable the car, and the car needed to connect to cloud service. So non-internet connection, the car can't connect to cloud service, and they can't start a car, and they can't go like away from the mountains.
That is
Have you heard? Sorry?
That is so cool. I didn't know that.
Yeah, they basically stuck, and they needed to call. They called the rental, but no help, and they needed to call like the evacuator like car to get them to the area with internet connection. Do you think this is like these things will happen more often because we will have all these smart devices, not even cars, smart kettles or smart fridges, or do you think we'll handle these issues somehow?
Well, this is a twofold answer. First of all, I wouldn't stop putting cloud-enabled services in the car just because there's no signal. I would use this as an incentive to have better signal everywhere, first of all. But
Okay, makes sense.
but second to that, obviously, everything is going to become connected, especially with the 5G coming on, everything will become connected. This table, this chair, everything is going to become connected for telemetry, user statistics, reports to the end user. You have this health issue, not this health. So everything is going to become connected. And they already are. I mean, we're there already. Kettles, they're connected. There's smart coffee makers, all that stuff, right? There's even a smart yoga mat, smart pillows, smart beds. Everything has started to become smart. And in some cases, there's not even an option to buy a dumb one. I mean, if you look at the smart TVs, all of the TVs are smart now, right? If you look at the printer, all printers are network connected now. So there's no more an option to get non-smart devices. So yes, definitely the whole buzz with an enhanced number of IoT devices, 30 billion, 50 billion, blah, blah, blah. It's not fake news. That's how it's going to be.
So if a person would like to hide somewhere from all the smart devices, they can do it and like living under the rock, and that's the only option. Or like in an island, and that's the only option we have, because people in cities, they will communicate with all the smart devices whether they want it or not, right?
Pretty much, yeah. And you have to take into account third-party threats, right? I mean, okay, I'm not using a smart device, but you are, and you are next to me. So that exposes me as well. So it's going to be very difficult to run away from that.
Okay, this is a very dark and dystopian kind of future.
No, this is reality right now.
Okay. Don't push on me. We already have this 2020. No, don't make things worse by saying that. Thank you. I just wanted to say thank you for your time and for the talk and for the question. That was really cool.
My pleasure. Anytime.
Thank you.